All right. Welcome everybody to the virtual RES Symposium. Thanks for joining us. My name is Erin McCormick. Also joining us today from RES is Dennis Root. We ask that you log in as the name you registered as, and you use the email address that you registered with. I understand that in order to rename yourself, you'll need to log back out and log back in. If you called in, we ask that you send an email to Dennis, dennis.roote@cde-pllc.com. You'll be kept muted, and your video will be off the entire presentation, including during Q&A. There will be an assessment of learning at the end. We ask that you answer the assessment of learning in Q&A. If your answer is the same as somebody else's, we would ask that you hit the like button. We'd ask that you use the chat function for Zoom related questions. You will receive an email following the presentation about your certificate. I don't have an exact time frame yet. RES will get permission from the speakers to release contact info to attendees, and that will be forthcoming. I'd like to introduce our speaker, Tim Franco, Manager of Commercial Sales Northeast at Pyro-10X MI Cable, which is a division of nVent. The title of his speech is Compliance with NEC Requirements for Fire Protection of Fire Pump and Emergency Feeders. Thank you.
Okay, thanks for the introduction, Erin. And welcome all. As Erin mentioned, my name is Tim Franco. I'm the Manager of Commercial Sales Northeast for Pyro-10X MI Cable. We are a division of nVent. And today we're going to talk about how to protect critical circuits from fire and how to comply with the requirements of Articles 695 and 700 of the NEC, which mandate fire protection of fire pump and emergency feeders. So let's get going. Briefly, nVent Thermal Management, we also offer heat tracing, floor heating, snow melt, roof gutter de-icing. I do not handle that. I have another counterpart who does. But if you're ever involved in that, you're not sure where to go, feel free to reach out to me as well, and I will steer you in the right direction. A little bit about what we're going to cover today, a little bit about the code requirements, various fire protection methods. We're going to talk about UL testing, the latest update from UL, latest updates, and of course we're going to talk about MI cable. And basically, MI cable, it's a 2-hour fire-rated mineral insulated cable. It's a 600-volt cable. We also manufacture fire alarm cable. We've got our own website, pyro10x.com, which has pretty much all the info you need to specify and work with our product. There's a little cutaway of MI cable now, but let me jump into it and explain how exactly MI is manufactured and what it is exactly. It has 3 major components: magnesium oxide, your copper conductors, and copper tubing. Now you'll also see nickel and nickel-clad copper. Those are for heavy-duty industrial type applications, very specific applications, but really what you're all going to be dealing with is the copper conductors and the copper sheeting, so I'm going to stick with that. So magnesium oxide, it's high temperature resistance, it's stable up to 5,000 degrees. It's an excellent insulant of electricity, but it's a poor insulant of heat. So the heat does dissipate right through the cable. It's completely non-toxic. Believe it or not, it's actually the same stuff you'd find in Phillips Mocha magnesia. So it's non-toxic, nothing to worry about if you have to inhale it, if the contractor's working with it on the site and he's terminating the cable and he happens to inhale some of it, it's completely harmless. When we manufacture the cable, what we do is we start out with that magnesium oxide, copper tubing that's about 2 inches in diameter and 30 feet long, and then copper conductors, which are at this moment copper bars that are about 30 feet long. And depending on how many conductors we're working with, anywhere from 1 up to 7. But it's about 30 feet long. So we take those copper bars and the copper tubes, and we place them vertically. What we then do is pack those tubes that are about 30 feet long with magnesium oxide. And when they're completely full, what we do is we take that 30-foot copper tube and we pull it through a series of reducing dies. And we keep repeating that process until we get to the desired cable size we're looking for. For example, if we're making our 500 kc mill, we'll stretch that 30-foot piece out to 200 feet. If we're making our single conductor number 8, we'll stretch it out to 1,500 feet. And so I should also hasten to add, you're certainly not limited to those lengths. For example, say you're working with our 500 kc mill and you have an extra long run, like here in Boston at the Hancock and Prudential buildings, I have runs that go about 700 feet. We have a 2-hour factory installed fire rated splice. We can just joint it together at the factory and give you a longer run if needed. And also, there's no minimum requirement. If you only need 10 feet of cable, we can cut you off 10 feet. So you're not really limited to any particular lengths. And when you're done, you've got a very rugged electrical cable system. Magnesium oxide, your copper conductors, and your copper sheet. And it's a product that's inherently resistant to high temperatures. As I mentioned, magnesium oxide is stable up to 5,000 degrees, and the melting point of copper is 1981 degrees. So again, it's inherently resistant to high temperatures. And here you can see a little photo of an installation. I'll get into that in a little more detail. I have more photos near the end of my presentation. And there's various ways of achieving protection, fire protection of these life safety circuits. There's the MI cable. You have MC cable on the market. You have your RHW cable. And then, of course, you have a circuit integrity type cable. Now, all of these cables, with the exception of MI, have run into listing problems with UL and have other issues, which I will get into later on in the presentation. Now, currently, the NEC, the code requirements, you have NFPA 20, which was later put into NFPA 70, the National Electric Code for fire pumps. And of course, you have NFPA 72, the fire alarm cable. Now, Article 695 requires 2-hour protection, and it's required that as far back as the 2008 NEC. So any fire pump feeder, both normal and emergency, are required to be fire rated for 2 hours if the feeder's running through the building. Article 700 requires 2-hour protection on emergency systems, and that's been since 2011. And Article 708, which is critical operating power systems, and I'll get into that a little more in a moment, that also requires 2-hour protection. That's been around since 2011. And then you have Article 728, which just expounds on the fire-rated systems that are permitted to be used. Also, you have Article 760, which gets into fire alarms and references NFPA 72, which does require a 2-hour survivable circuit for certain types of fire alarms. Now, typically, where do you typically see these wires needs for fire-rated wiring? Of course, a generator, fire pump, fire alarm control unit, firefighters' elevators, smoke extraction fans, and pressurization fans. Typical locations: high-rise buildings, hospitals, other institutions, historic buildings, tunnels, subways, airports, stadiums, hotels. As I mentioned, also critical operation power systems. If you have a vertical shaft with 2-hour fire-rated cable, no fire-rated separation is necessary. So for example, say sometimes you're building a brand new building and you do have a dedicated shaft in the center that is 2-hour fire-rated. It's a 2-hour fire-rated shaft. Nothing alien to the emergency, if you're going to run emergency feeders in that shaft, nothing alien to the emergency system can be in that shaft. If anything else alien to the emergency system is in that shaft, then you cannot use it as a fire-rated shaft. However, if you run MI cable in that shaft, you could run whatever else you want in that shaft because MI cable is a 2-hour fire rating in and of itself. And Article 700 requires emergency systems meet these requirements. So basically, when you have a building that houses 1,000 people or more, or above 75 feet in height, you're gonna need to have those feeders fire rated for 2 hours. Again, if you have a high-rise building, or if you have a building that exceeds occupancy of 1,000 people, you will need to have fire-rated emergency feeders in that building. Also, the 2017 NEC added that the 2017 NEC added that educational occupancies of 300 persons or over are also required to have 2-hour fire-rated emergency feeders. So that's pretty much going to be just about any school you're working with, or most schools. They will be required to have fire-rated emergency feeders. That's important to know about. Most people knew about the height requirement above 75 feet in height or greater than 1,000 people, but this is one a lot of people are just becoming aware of. So again, if you have a school with 300 or more people, those emergency feeders will need to be fire-rated. Okay, you heard me mention before Article 708, Critical Operation Power Systems, otherwise known as COPS. This was brought about as a result of Hurricane Katrina. That was the main driver behind this. And it's basically stating that if you have any building that's going to be used as a command center in the event of a local or national emergency, every feeder in that building not only must be fire rated for 2 hours, but they also need to be protected against physical damage. This is not only emergency feeders, but normal feeders as well. So say you've got a police station or a fire station, and this is going to be, say there's a local or national emergency where it's going to be used as a command center. Every feeder in that building must not only be 2-hour fire rated, but also must be protected against physical damage, and has to be either RMC, IMC, or type MI cable. You cannot use EMT. Okay, and as I mentioned also, there is Article 728 in the NEC, and that basically covers all the requirements that fire-rated cables must comply with before they are used. And they have something interesting there, that there's no interchangeable components between systems that are allowed. So basically what they're saying is whatever the cable is supported to has to be tested with that cable. So anything used with that system has to have been tested, and you can't do a hodgepodge of systems. They have to be tested together. You do have, as I mentioned before, NFPA 72 requires survivability on all circuits from the fire alarm control panel to the first notification appliance in each zone when you have a partial evacuation system. So again, from the fire alarm control panel to the first notification appliance in each zone when you have a partial evacuation system. What is a partial evacuation system? Generally find them in high-rise buildings or buildings with several wings. So for example, they may say floors 4 and above, you stay put, floors 3 and below, you evacuate. So when you have a partial evacuation system, the circuit from the fire alarm control panel to the first notification appliance in each zone must be fire rated for a period of 2 hours. One thing for emergency feeders, if the emergency feeder is directly protected by a fire suppression system, the feeder would not have to be fire rated. Now note the note where it says right here, where emergency system feeders are installed above a suspended ceiling, for the system to be fully protected by a fire suppression system, sprinklers must be provided above the suspended ceiling, even though sprinklers might be installed below the ceiling. So basically, if you have a suspended ceiling and you have sprinkler heads coming out of the ceiling, and you have an emergency feeder running above that ceiling, unless there's sprinkler heads up there, which there's not going to be, more than likely, that feeder is going to have to be fire rated. The feeder must be protected by the sprinkler system for the entire run. And actually, not long ago, I had a situation down in Hartford, Connecticut, where the building was sprinklered, but it was not protecting the emergency feeders. And the inspector called out the contractor and the engineer, and they ended up installing MI cable because the sprinkler system was not directly protecting the feeder. So in most of my years of experience on this job, which are many, very rarely do you have a situation where the emergency feeder is protecting the circuit for the entire length of the run. So more often than not, with an emergency feeder, you're going to be using fire-rated MI cable. For fire pumps, for a fire pump feeder, it doesn't matter about height, occupancy, sprinkler, no sprinkler. All fire pump feeders, regardless, again, of height or occupancy, or whether the building is sprinklered or not, or whether the feeder is directly protected or not, they all have to be fire rated for 2 hours. Okay, now there are some methods, there are options. Construction methods being encased in a minimum of 2 inches of concrete is acceptable for the code. And also drywall enclosures are acceptable. But it's important to know, just as people in the construction and engineering community, that neither concrete or gypsum enclosures are tested or listed for the protection of electrical conductors, even though they are approved. They're basically both fire tested only for flame passage prevention and to verify that on the unexposed side, the temperature does not exceed 325 degrees maximum above the ambient temperature. And what makes that rather telling is a few years ago, testing was done by Warnock Kersey Laboratories, where unprotected conduit wire was tested, and it was found that the temperature failed at the cable failed at 450 degrees Fahrenheit. And what happens is, even when you're using rigid pipe, the heat goes right through the pipe, melts the thermoplastic insulation on the cable, and the cable shorts out against the pipe. And again, that happens at a fairly low temperature, 450 degrees Fahrenheit. And the 2 inches of concrete, actually, this is kind of an interesting slide here from NFPA's Fire Protection Handbook, which shows the temperature gradient in a 6-inch slab after 2-hour exposure. Now, why a 6-inch slab? Because they're figuring you'd have a 2-inch pipe and then 2 inches of coverage above it and below it and on each side. So it'll give you a 6-inch slab. But you can see after 2 hours, the temperature reached is 675 degrees Fahrenheit. That's more than 200 degrees hotter than what a circuit was shown to carbonize at when it wasn't protected. So 2 inches of concrete will not give you the requisite protection for a critical circuit. And in fact, NFPA actually just recently did some testing, and they did a white paper on it, and they found to basically achieve a 2-hour rating, you're going to need close to 5 inches of concrete, depending on which type is used. But siliceous aggregate, which I believe is what most construction sites use, you're looking at basically 5 inches of concrete. And so they actually, NFPA did their own white paper on this, where that backed up that. And because NFPA also publishes the NEC, we are expecting the next code cycle for the NFPA to up its requirement to 4 or maybe 5 inches of concrete, up from the present 2 inches of concrete, because now it's pretty obvious that 2 inches of concrete will not give you the protection that you need. And it, you know, if anyone likes, we do have this white paper available. Probably, this is an interesting slide on 2 fronts. First off, it shows what can happen with concrete. And it also shows probably the most rigid test, real-life test MI cable has ever received. And this was in the tunnel that goes from England to France. And basically, there was a fire there. It was around 2000. And the heat got so intense, you can see the concrete, chunks of concrete just fell away, because concrete contains moisture. When moisture is exposed to heat, the moisture expands, the concrete just starts to fall away, otherwise known as spalling. The MI cable withstood that intense heat, powered the emergency lighting, and even operated in the aftermath when they went in to clean up during the tunnel. So that was, and then that's an interesting slide, and shows just how robust and durable MI cable is. And then also, you can build a drywall enclosure. Again, these have a lot of the same shortfalls as concrete encasement do have. They're very difficult to build. They have to be done per UL requirements. This is a little more of a simplified sketch. There are different versions, but they're all basically the same, where you need drywall, steel studs, and then more drywall. And then the circuit has to go behind the wall, not in the cavity of the wall, but behind it. So you can see, if you've got a vertical shaft going up a brand new building, yeah, you can do this. But if you have a horizontal run or run in an existing building, this is going to be very difficult to do, because it takes up a lot of space. It's trade sensitive. And then over time, issues arise. You can see by this slide right here, someone needed to run some conduit. The enclosure was in its way, so the guy just poked a hole through the enclosure with this conduit, compromising the system. Also, over time, they deteriorate, they fall, they begin to fall apart. Now you can see, because this is falling apart, this would offer absolutely no protection at all in the event of a fire. The fire would go right through that. So now, the best option, what I mentioned before, are the listed electrical circuit protective systems with a 2-hour rating, of course, which MI is one of them. And I will talk a little bit about the UL test. It's basically a 2-hour fire test, followed up by a water hose stream test, where the cable on the conclusion of the fire test is hit with a 30 PSI fire hose stream. Very powerful, enough to knock a person off their feet. And right before that test, the cables are disconnected. The power is disconnected for safety reasons. then it's hit with the hose, and the cables are energized afterwards. And once it's been confirmed that circuit integrity has been maintained, your cable is deemed to have passed the test. The test is done per the ASTM E119 time temperature curve. And that basically, it's American Standards test measurements, and it simulates the rise in a real life fire. So for the first 5 minutes, you're going to go from 0 to 1,000 degrees Fahrenheit. After about a half hour, you're going to be up over 1,500 degrees. And the test maxes out at 1,850 degrees after 2 hours. And here you can see a picture of the some cable going in for a UL test. And while the cable is in there for the UL test, you can see on the right that some light bulbs are being powered. Those light bulbs, if any of them go out during the test or fail to come on after the hose stream test, your cable has failed the test. There's a shot of inside of the furnace. It's quite a rigorous test. And basically, as I mentioned before, everything associated with the system, the supports, splices, everything must be tested to be used, and you can't have any interchangeable parts. As I also mentioned earlier, all of these cables, with the exception of MI, have run into listing issues. And in the late 90s, the polymer cables were first introduced to the market, and then they were delisted in 2012 because UL found a big inconsistency in their testing. When they realized they had not tested the cable properly, and when they tested the cable properly, they found the fail ratio to be, I believe, around 70%, which is just completely unacceptable. I mean, you want it to be 100%. This is life safety. A 300 batting average may be good in Major League Baseball, but it won't cut it for life safety systems. So the polymer cables were delisted, and then a new testing was put in place. And I'm going to expound on that a little bit more later in the presentation. But the big favorability with MI cable, and why it is far and away the most popular cable on the market, particularly with engineers, is that it's completely inorganic, gives off zero smoke, zero flame spread, zero fuel contributed to the fire. It's a smaller diameter cable. It's got a small bending radius. You can bend it, the size is 250 and smaller, up to 5 times the OD of the cable. And 350 and 500, you can bend 10 times the OD of the cable. And also, per table NEC 31015B, you can use a free air rating with our single conductor cables. So that does give it a big ampacity advantage. For example, our 500 kc mil cable has an ampacity rating of 620 amps with a free air rating. And a lot of the, all the other single conductor cables have the free air rating as well. Our 250 kc mil is rated at 405 amps. So it does give you a bit of an advantage there. There you go, right there. Our 500 kc mil, 620 amps, and THHN 380. Now, this is very important, what I'm going to add here. The voltage drop for the MI cable is exactly the same as it is for pipe and wire for other cable systems. It's exactly the same. However, when you use our free air rating or any cable's free air rating, you will experience greater voltage drop for the simple reason that you're pushing more current through a cross-sectional area. So a good rule of thumb is if you're working with 480 volts, 300 feet or less, you can pretty much take the free air rating at face value of 3% voltage drop is acceptable. 208 volts 125 feet. Now, of course, on our website, pyro10x.com, we've got a voltage drop calculator where you can just plug in the run length, the voltage, the current, hit the calculate button, and it'll tell you what your amperage is. Probably what I'd say 70% of the engineers I deal with do is they just spec the same size MI as they would pipe and wire. If they do that, you'll always be covered because you would never need a larger size MI than you would pipe and wire. About 30% like to take advantage of the free air rating. Either or is fine. But again, with the free air rating, be mindful that because you are pushing more current through a cross-sectional area, you will get a bit more voltage drop. So good rule of thumb, 300 feet at 480 volts, 300 feet or less, 480 volts, you're going to be good. 125 feet or less at 208, you're going to be good. Once you start to exceed those, you want to go to our website and check the voltage drop on our calculator. No conduit needed. Note this installation photo here. It's a good photo. The cable is required to be supported every 6 feet horizontally, 6 feet vertically, and you bundle them together, ABC, neutral if there's a neutral. So you bundle them together like that. And the reason why you bundle them together is so you get the sheath currents, which will rotate around the cable. You get them to cancel each other out. If you don't bundle them together, the sheath currents could create an induced voltage, which could manifest itself as voltage drop along the run of the cable. So, of course, what you support and bundle the cable with has to have a fire rating for 2 hours. So we recommend, we require rather, steel supports. Unistrut works great. And steel clips. Stainless steel hose clamps are fine. We have our own steel clips you can use, but that's what we require for fire rated applications. Now, by chance, if you happen to be using MI cable for a non-fire rated application, then you could support it on whatever you want because it's not being used for a fire rated application. But when it's used for a fire rated application, you do need a 2 hour fire rated support system. And we come in a wide variety of sizes, 600 volt, single conductor, 16 to 500 kc mil, multi-conductor cable. We usually start, our largest is probably a number 4.3 conductor, and we do go up to 7 conductors in certain sizes. But with the larger size cables, we generally use multiple runs of single conductor. I'll show you a few photos we have here. You can see the cable supported. Again, these are some detailed drawings. Again, cable supported every 6 feet horizontally and vertically on steel systems. Interesting slide here. Note those brass entry plates that the cable is passing through. As per the NEC, when you have individual conductors penetrating a ferrous enclosure, there is the potential for induction heating to take place. So in order to prevent any induction heating, when you're using our single conductor cables, we require a brass entry plate, which we supply, that the cables pass through them, so to prevent any induction heating. So what the contractor does would cut a rectangular hole in the top of the box, bolt the brass plate to the box. The brass plates are tapped, or threaded glands will screw right into them. And so that would comply with the NEC's requirements. If by chance you're using one of our multi-conductor cables, no brass plate is required. Just use a regular lock nut and you'll be fine. Got some more installation photos. Every now and then I get asked, suppose you're crossing an expansion joint. This is what you do, just put a little semicircle and expansion loop in it. It's a good photo there. Here's some more photos, good installation photos. Another good shot there. And again, when you have the bundles of cable, if the free air rating is used, you want to keep the bundles 2.14 diameters. You want to keep the spacing 2.14 cable OD diameters between them. So for example, if you're working with our 500 KC mill, which has an OD of 1 inch, you want the two bundles, you know, the ABC neutral, or whatever, if they're running adjacent to one another, you want them to be slightly over 2 inches apart from each other, each bundle, if the FRIA rating is being used. On our website, we have pretty much all the information you need for installation, for doing mega testing and whatnot. This is a good slide here. And I always ask engineers and contractors, of course, MI cable is a natural for for fire rated applications. But keep it in mind for non-fire rated applications, because maybe once a year, twice a year, you may be working in a situation where space is at such a premium, you don't have room for pipe and wire. So say, for example, you have a situation like this, you have a 1200 amp feed, you have to fit through a 4-inch square opening. With pipe and wire, you're going to need 4 runs per phase of 5 or 600 KC mill, and you won't be able to do it. But if you have MI cable and you had the right circumstances for voltage drop, say it's 300 feet or less with the 480 volts, you could use 2 runs per phase of our 500 KC mill and fit the cable in there. So it's a good thing for both engineers and contractors to keep in mind. In fact, quite a few of our non-fire rated applications get initiated by the contractor, because maybe there might be a time where the engineer might not be aware of how dire the space situation is out there, and the contractor thinks of it and brings it to the attention of the engineer, and the engineer's like, oh, of course, yeah, sure, MI cable, great. But it's a good thing to keep in the back of your mind. Now, what I was talking about before, the polymeric cables, they had their listing problems, and they've got another problem, which really is probably the biggest concern to the engineering and contracting community, and that is the smoke that it gives off is highly, highly flammable, which is very ironic given that it's a fire-rated cable. And the reason it gives off this smoke is these cables, unlike your regular cables, these cables are insulated with silicon rubber, and silicon rubber produces a highly flammable off-gassing known as, the compound is known as hexamethyl cyclotrisioxane, otherwise known as HCMS. And the real danger is once that MC jacketing heats up from the MC cable, there's only 2 directions that smoke can go, left and right. And where's it going to go? It's going to go right into a box fitted with a breaker, and you're going to have something like this happen. There's a contactor in that box, and look what happened. Something like that happens, you lose all your gear, you lose your emergency power. This is something, as I mentioned, engineers, I'm in Massachusetts. Massachusetts is really ground zero for fire-rated cable because they were the first in the nation. And this is good to know in case you ever have to be doing work here. Massachusetts requires 2-hour fire-rated feeders in all buildings, regardless of height or occupancy. And the engineering community is just very concerned about liability, and rightfully so. And MI cable is pretty much all they accept down here. They just don't want to take any chances because crazy things can happen in a fire. And something like this isn't so far-fetched. As I said, when that MC jacketing heats up, there's only 2 directions that smoke can go, left and right, and it's going to get funneled right into a box fitted with some type of arcing device. And you saw what would happen. Okay, I think we have reached our conclusion. I have a couple of questions I'm going to put up. I would ask that you look, and we'll take them one at a time. Aaron, did you want to, before I put up the questions, did you want to add anything about the Q&A?
No, just respond to the assessment of learning via Q&A, and then
Okay,
we'll
all right,
read out some answers. Yeah, we'll just go one by one.
Here we go. The
One-
first
one by
one.
one. Go ahead.
The first question, per the NEC, how many hours do the fire pump feeders, both normal and emergency, need to be rated for?
Is that 2?
That would, yes,
2,
yes.
pretty much.
Ready for the second question?
Yep.
Okay. Second question, per the NEC, name the 3 instances when emergency feeders need to be fire rated and for how long must they be fire rated?
Aaron, go ahead. You
High rise.
That's one.
High-rise fire pump critical alarms
Okay, it's
in
fire
2
pump,
hours.
2 hours, and it's when you have a high-rise building, a building that houses 1,000 or more people, or an educational or a school with 300 or more people. And 2 hours.
More than 75 feet, more than 1,000 people. That's
Yep.
2-hour rating.
Or schools with more than 300 people. And it must be 2 hours. Now, the next one, I've got to apologize for because I meant to mention this in my presentation. And I sidetracked myself there for a second and I didn't. So can I answer this question because I forgot to mention it in my presentation?
Yeah, that'd be
okay. Per the NEC, I asked, can you use a fire-rated MC cable for an emergency feeder in a hospital? The answer is no. And I meant to mention that during my presentation. And the reason is Article 517 hospitals of the NEC requires that all emergency feeders be mechanically protected. So only rigid, non-flexible conduit or type MI cable is permitted to be used for an emergency feeder in a hospital. So you cannot use fire-rated MC cable in hospitals for fire-rated feeders. Sorry, I meant to mention that in my presentation. I sidetracked myself there. So that is important to know. And then the last one, per NFPA 72, with what type of alarm system are you required to fire rate the feeders from the control panel to the first notification appliance in each zone? What type of fire alarm system would require that
partial evacuation?
Yes. Yes. That is correct.
Okay, let's see here. Yep, that's the answers that we're by and large we're getting.
Okay, now I see under Q&A, it looks like we have around 13, 12, 13 minutes going down.
We've got some, yeah, let's see here. The first one we have, can these be pulled through conduit?
It can only, the cable is not designed to be pulled through conduit. If you have a short straight sleeve, going through from one room to another, it's a short straight sleeve. Yes, you can pull it through conduit, but the cable, for it to be pulled through a long run of conduit, particularly twists and turns, no, it's not designed for that. And it's not, this cable is quite strong mechanically. I should add, it can withstand 120,000 PSI. You can crush this cable to half its diameter and it'll still remain electrically functional. And that's because the density of the magnesium oxide is denser than than the copper. And so, as I said, you can crush this cable and the copper still won't come in contact with the sheet because the density of the magnesium oxide is so great.
How about another one? How is the MI cable marked so it can be recognized as not AC copper? Whoops. Let's see
Okay,
something else.
good question.
Copper, water tubing, etc.
Well, knock on wood, fortunately, we haven't had anyone mistake it for a water pipe, but we take every precaution. We do mark the cable with an inkjet continually before it's shipped out of the factory. So it's, continuing marked, maybe with a 3 or 4 foot gap in between the markings. It says 600 volt cable, but also we have cable ID stickers that say 600 volt cable, which are available from us that you can put on there for an extra measure of precaution.
All right, we have, is the exterior of the MI cable considered an equipment grounding conductor?
Yes, it is. Another good question. Yes, it is. Per the NEC, there's more than enough copper in the sheet to use to serve as the ground.
Great. Another question, is the casing of the MI cable metallic? It looks like copper plumbing pipe in the photos.
Well, it is copper. As I said, the 3 components of our cable are copper, or the 2 components are copper and magnesium oxide. So it is copper.
Okay, another question, if you have a fire protection sprinkler system in the building, wouldn't it be easier to have sprinkler heads above the ceiling to protect the feeder?
Again, for emergency feeders, that is permissible if the sprinkler system is directly protecting the feeder. However, putting the sprinkler heads above the ceiling can be very costly. Particularly, most systems are designed where the sprinkler head is coming from the suspended ceiling directly into the room, and it's putting the heads above. In addition, is a great expense, and ensuring those heads are protecting that circuit for the entire run is also quite costly. So at the end of the day, using a fire-rated cable is going to be much less expensive than installing a sprinkler system dedicated to directly protecting the emergency feeder. And also, again,
Okay.
I just want to add one more time, for fire pump feeders, the sprinkler system is not an option. Whether you have it or not, that feeder has to be fire rated, both normal and emergency.
Another question, what are the limits for the bending radius? Is it typical for conduit?
No, it's a little different, and it's actually better than conduit. The bending radius, 5 times the OD for 250 and smaller, so you can put a pretty tight bend in that. The OD of our 250 is, I believe, 3/4 of an inch, and for our 350 and 500 kc mill cables, it's 10 times the OD. So you can put a pretty good bend in this cable.
How much can the cable be bent before the fire rating's impacted?
We can put as many bends in it as you want. It's not going to hurt it. And quite honestly, even if you exceeded those bending radiuses, which I think you'd have a hard time doing, I mean, those are pretty sharp bends. I feel pretty confident, even though it would go beyond what the code allows. I mean, this cable is pretty rugged stuff. Yeah, it's as close to indestructible as you can get.
Here, I think we have one more.
Yep. How is the annular space magnesium oxide stabilized at junctions where the casing is peeled back?
The magnesium oxide, as you recall the manufacturing process, we start out with a 30-foot copper tube, roughly 2 inches in diameter, and we pack that. It's really very interesting. If you ever get the opportunity to come to our factory, and I've had several engineers and contractors up there, but it's packed in. It's packed in. The conductors are held in place with valves, and the cable is just pulled through a series of reducing dies. So you've got a cable slightly over 2 inches in diameter, in some instances getting reduced to almost 1/4 of an inch, or in its largest size up to 1 inch. So it's under such extreme pressure, it becomes essentially one homogeneous mass. So when you terminate the cable and peel it away, yes, that magnesium oxide, once you peel the copper sheath away, you go back a few inches, that'll crumble away, but the other stuff is in there, it's in there solid.
Okay.
Great. I don't see any other questions. I'd like to thank you very much. Do you have anything else, Dennis?
I don't. We're going to go ahead and end this. Tim, thank you very, very much. And
Okay.
we will see everybody else for the 18th of 18 webinars in the Rochester Engineering Society virtual symposium. We'll see you back here in about half an hour.
And I would just like to add real quick, Dennis and Aaron have my contact information. Please feel free to reach out to them, and feel free to reach out to me anytime. I'm happy to assist any way I can, and I'd like to thank all of you for attending.
Oh, all right. By the way, we just got one more question. Voltage ratings.
Sure.
What are the voltage ratings for this?
Oh, I'm sorry, voltage rating, 600 volt cable, and our fire alarm cable is 300 volt.
Alrighty.
Great.
Go ahead.
Well, thank you.
Okay.
Very much.
Okay. Thanks again, everyone.
Thank you. Okay,
Okay,
folks, we're going to
take
end
care.
this now.